Okay. We'll wait for another 2-3 minutes, and then now it is 6:01. So we'll another 2-3. I mean, wait for a few minutes, and then. Yeah, I think we can start. I think. Because Nikolai, recording is still on, is it? Yeah. Okay.
Yeah, it has come now. Yes.
Good evening to one and all. On behalf of the organizing units, Computer Society of India, Chennai chapter, ACM Chennai chapter, IEEE Computer Society Madras chapter, I extend a warm welcome to our resource persons, Ms. Nalini, Mr. Dhruv, and Dr. Mohit, who have been breathing IPv6 and have done significant contribution in creating awareness and assisting in the migration process. Hearty welcome to all the participants and my colleagues at CSI, ACM, and IEEE CS who are joining through Google Meet and YouTube streaming in this evening program from across the country and from outside India. We have noticed few overseas registrations. Today's topic, IPv6 migration, need, issues, and process is a timely one. But the migration from IPv4 to IPv6 is not a new topic. It has been there for over 10 years. It has become an issue of high priority now since the cutoff date for the migration is nearing. At CSI and IEEE Computer Society Chennai chapters, in 2014-15, we had organized several awareness programs and workshops to facilitate the migration. IPv6 is one of the building blocks for new protocols at the Internet Engineering Task Force. For example, much of the new work in the areas of Internet of Things and machine-to-machine communication require IPv6. Besides solving the address depletion problem, IPv6 brings advantages like delay efficient routing and packet processing, better security measures, simplified network configuration, and proper end-to-end connectivity for peer-to-peer applications. Having said that, migration, especially for large end-user organizations, comes with some challenges in revising operational procedures and understanding the complexities of the new protocol. This talk will discuss the motivation to migrate university campus networks to IPv6, the significance of being IPv ready, and the challenges and opportunities depending on the experience gained while migrating a university campus network to IPv6 in India. These might as well apply to other universities and organizations in the Asia Pacific region and other countries. Additionally, the experiences of two organizations, India Internet Engineering Society and Industry Network Technology Council, actively working on IPv6 deployments, will also be discussed. While Ms. Nalini will set the stage by briefing about the need for IPv6 migration, Mr. Dhruv will highlight the issues following which Dr. Mohit will explain the process of migration with an use case of his own institution. With this brief note on the today's event, let me formally introduce our resource persons. First, let me introduce Ms. Nalini Elkins. Ms. Nalini is the founder and CEO of Insight Products, a high-tech software company developing network management and diagnostic products. And she is also the president and co-founder of Industry Network Technology Council, a non-profit consortium of industry, government, and academia. Ms. Nalini specializes in protocol analysis, deployment, and engineering. Her specialties include performance management on wide area broadband networks, IPv6, and network security. Her software products have been OEM by IBM and other large software vendors. Ms. Nalini is the co-author of RFC 8250, dealing with embedded performance diagnostics and monitoring for IPv6, and quite a few RFCs produced by the IETF, which is nothing but the Internet Engineering Task Force. She has taught networking and protocol classes to Fortune 500 level companies globally. And incidentally, Industry Network Technology Council has been organizing a series of webinars and workshops for IPv6 and related deployment. And in fact, in one of our communication to our members, we have shared the recorded proceedings of these workshops. Coming to Mr. Dhruv, he has been working in the networking domain for the last 18 years with FUI Technologies. His current designation is Chief Architect for Standards for Data Communication business in India. Over the years, she has worked on MPLS, VPN, OSPF, NTP, ALTO, CSPF, etc. for wire routing platform. He is currently working on research and standards for various emerging technologies such as PCE, segment routing, and network slicing. Mr. Dhruv is an active Internet Engineering Task Force contributor in the area of path computation and traffic engineering with 32 RFCs as main author or contributor. He has filed for 21 patents. He currently serves as the PCE Working Group Co-Chair at IETF. Additionally, he is part of Routing Directorate and Sergeant at Arms for IETF mailing list. He is a founding member and secretary of Industry Network Technology Council, which has been co-founded by Ms. Nalini. Mr. Dhruv was awarded the Technical Role Nodal Award by Zinov, a management consultant, and recognized the technology stalwart in India. Coming to Dr. Mohit, Dr. Mohit Tahiliani is an assistant professor of computer science and engineering at National Institute of Technology, Karnataka at Surathkal, popularly known as NIT Surathkal, and a member of board of India Internet Engineering Society. She obtained his PhD in the area of congestion control mechanisms for the next generation internet from NIT Surathkal in 2013. His area of interest include network congestion control, Q disciplines, network function virtualization, deterministic networking, IPv6 deployments, named data networks, and distributed ledger technology, which is popularly known as blockchain technology. He has executed projects in these areas and have been funded by Intel Technology India Private Limited, ABB Global Industries and Services, Robert Bosch Engineering and Business Solutions, and FutureWell Technologies in US. Mohit received the EMC Young Achiever of 2015 award from EMC Corporation and Outstanding Professional Volunteer Award of 2021 by IEEE Bangalore section. Mohit has contributed to open source project for more than a decade. A packet scheduler deployed by his team at NIT Surathkal to fight the buffer bloat problem got merged in the mainline of Linux kernel version 5.6. He is a member of the steering committee of the NS3, that is a Network Simulation Consortium, and a co-maintainer of traffic control and TCP modules in NS3. He has served as a member of the PC for Workshop on NS3 for the past 8 editions. Besides, Dr. Mohit has served as mentor for Google Summer Code from 2017 to 2020 for NS3 organization and is one of the organization administrators for 2021. He also has served as an organizational administrator for NS3 participation in Google Code during 2018 and 2019. He has 45 plus technical publications in peer-reviewed international conferences and journals. Dr. Mohit is a reviewer for IEEE Internet of Things, IEEE Transactions on Cloud Computing, Elsevier Journal of Network and Computer Applications, Computer Communications, InterScience Journals, IEEE Communication Letters, and held several other roles in IEEE and Springer conferences. She has served as a guest editor for Annals of Telecommunication, a Springer journal. He is a senior member of IEEE and was a student activity chair of IEEE Bangalore subsection during 2015 to 2017 and a member of the executive committee of IEEE Bangalore subsection for 6 years. He is the current secretary of IEEE Bangalore subsection. He is also a member of ASEAN. Once again, it is my pleasure to welcome everyone and request Ms. Nalini to pitch in and set the stage for today's program. Over to Ms. Nalini, please.
Yes. Can you hear me okay?
Yes.
Yes. Thank you so much for the kind introduction. So Mohit, if you'll go ahead and show the slides, that will be perfect.
Yeah. Do you see the slides, Nalini, now?
Yes. Yes, we see the slides. So next slide, please.
Okay.
So let me set the stage. First, as Mohan sir said, we need to migrate from IPv4 to IPv6. So what is this IPv6 and what is this IPv4? So today, every network device has an address, and the problem is that we are running out of addresses. You can imagine to yourself, for example, if your community has too many cell phones or too many devices, then at some point the telephone company has to renumber. Well, this is the problem with internet numbers, what we call IP addresses. Actually, a very, very long time ago, for example, 1980, the thought came to many people at the IETF that we are running out. And so, you think to yourself, this is 2021, we're still talking about this? Well, the difficulty is to renumber everything all across the internet, across the world. This is not an easy job. This is not an easy job because everybody has to renumber. The cell phone manufacturer has to renumber, everyone. And so now the governments have gotten into the action, if you will. United States government has mandate, Indian government has mandate. And so this brings us to now. So Mohit, next slide, please. So today, in the world, usage of IPv6 is going higher, and higher. And this has to be because we don't have an alternative. As difficult as the transition is, we cannot stay with IPv4 if people across the world are to join. We have to go to IPv6. And you can see things are climbing. But the thing is, most of these people are at the home. The people in their homes with their cell phones and so on are joining. Next slide, please. So what about India itself? India is doing very, very well. I believe India is leading in IPv6 deployment. And this is because some very, very large internet service providers, I think you can guess who, are leading the charge. This is very good effort for India. Again, though, I will warn you, this is home user. And next slide, please. So where is the problem? And why does this problem exist? And our entire project, and this is why the Industry Network Technology Council and IIESoc are working on this, is Industry Network Technology Council, our job, and Dhruv will introduce more about this, is to help enterprises, which is very large organizations, the business community, the government community, large universities, academia. And it is here that there is the problem. And so then we'll talk about why. So next slide, please. So why? Why does this even matter? Because, your bank, your government agencies, all of these things, traditionally, these are called enterprises, and traditionally they're private managed networks, meaning that the company itself or the agency itself runs the network. They have their own servers, they lease their own telephone lines and so forth. This is slowly moving to cloud, but still, you can't just say, I will move to cloud, all my problems are over. That's a whole different situation about IPv6 situation at the various cloud vendors. Also, even if you move to cloud, you are still managing, and people have privately managed, and it still has to go into your system. So this is not problem solved by any means. Next slide, please. So let's look in the U.S. Let's look. So I just did a list of the Fortune 500. Let's just look at the top 10. And you can see this is going to the website. This is just going to the website, and of course going to CDN for the website, because the address will be different depending on where you are. You can see many of these addresses are IPv4 addresses. They will resolve to IPv4. But you know to yourself, this is not the only thing. Just because your website is IPv6 in some ways means really nothing. Well, it means that your website is IPv6, and so it should at least be dual stack. You look at Apple. Apple is dual stack. They have V6 facing. If you look at Amazon, even, it's IPv4. But then I will tell you, AWS has very good IPv6 support. We will be speaking on this at our webinars. Next slide, please. So let's look at India. Again, you look at the top few companies. You look at Reliance. Look at Reliance. You know to yourself, of course, Reliance has IPv6. But their website is IPv4. But look at State Bank of India, Tata. They have V6 facing websites. But why not everyone? Next slide, please. So this is a lot of what we have been working on in the past year and will continue to work on. Why have people not converted to V6? Why is there much more V4 than we want? And what is the issue with these large organizations not converting? And Mohit will tell you a great deal about how his organization, what his organization has done. But when you ask me why people have not changed, it's a very, very long process. Let me just give you one anecdote. For example, I was talking to one very large agency in the United States, and they said they talked to one vendor, and they said, he said how to convert to IPv6, and they gave him some three PowerPoint slides, and we were both like, oh my God. We have been talking for 1 year already on setting the base for converting to IPv6. And it's a 5 to 10 year process for many organizations to convert. You have to convert everything, your load balancers, your operational, your disaster recovery, redo all your security. So even once you know, and even knowing is very difficult. As I'm saying, we have spent 1 year giving you the webinars to give you the basics so you can understand. So this is why people have not converted. And I don't mean to scare you. You have to start. What do they say in China is a journey of 1,000 miles starts with one step. Well, let's take this step. Next foil, please. And then this is what we're trying to help you do. Get the training, think about what the major problems will be, and also deployment planning assistance. And we hope to tell you a great deal more about that. Stay tuned. We may have collaborations coming up, even with IEEE. As I say, stay tuned in this area. Next foil, please. These are the classes I've been talking about. All the recordings, all the foils are available. I suggest that you start going through. Send us questions if you have questions. And we will give you more links later. Next foil, please. So let me now turn over to Dhruv, and he will tell you about our various organizations. Thank you so much for your time.
Thank you, Nalini. And let me just give you a very quick introduction of the various organizations that were mentioned in the introduction. So next slide, please. So before we jump into it, I just wanted to give a very quick understanding of why, IETF even exists. So the main aim is IETF is a premier standard organization, and in the space of internet, standards are must for interoperability. We all do realizes that when we have various operators, vendors, different products, so many different stakeholders involved, we need these standards written down, and so that various products and services can work with each other seamlessly. And that's where the internet standards comes into place. And IETF is the premier organization when it comes to internet standards, and those are called RFCs. So we have been working in the IETF space for a while. The mission of the IETF is to make internet work better and produce high quality documents. It's an open international community. There is network designers, operators, vendors, researchers, all coming together and working on various different protocols and areas, all working together. This is a multi-stakeholder world. So what we basically need is, we need to make sure that there is a participation from all the stakeholders. And in internet standards, of course, the issues faced maybe in India and Africa may be a little different from what's happening in the West. So it's important that the participation is there from all stakeholders. And similarly, in terms of internet standards, they are not just used at home or on mobile networks, they are used even inside your enterprises. So even folks inside the enterprises needs to participate in the development of internet standards if they want their needs to be taken care during protocol evolution. So that's why the participation at this internet standards and IETF is very important. And that's where IIESoc and INTC comes in. Next slide, please. So we were seeing, the participation from India was quite lagging at IETF, and some of us who were the regular IETFers from India and people who have, like Nalini, who are a part of our large Indian diaspora. So we all worked saying, what can we do? How can we increase participation? The first thing that we did, we set up this small entity, a non-profit entity, which is working with stakeholders in India and the region, and trying to bridge the gap between the IETF community and the community who is here, from industry, from academia, from service provider, and even our Indian government. So our aim is to adopt IETF standards, IPv6 being one of the key one, increase the awareness and participation in the IETF standard development process. And we have been doing that since 2017. Next slide. What do? We do webinars, the one that Nalini talked about, IPv6 webinar being one of our key activities. We do RFCs we love, which is informal meetup talking about things. I have a small details on these things as well. I'll go in detail then. We do an annual connections event, which is our pre or post IETF event, where we try to bridge the gap that we were talking about earlier. And when we used to meet face-to-face at IETF meeting, we used to help the Indian community out, organize get-together, introduce them to the key people, and help them manage the IETF week. So that's what we do. We are here to help, mentor, and provide whatever help that we can when it comes to participation in IETF. Next slide. INTC is a similar organization. It's based in US. It's again a non-profit, but its main aim is taking enterprises' need into IETF. And as I was mentioning, that this is something that IETF has struggled. It is dominated by internet service providers and vendors, but we do not see input coming in from enterprises. So for that purpose, we made this organization so that we can again bridge that gap between the enterprise world and the internet standard organization. One of the key activities that we took was the webinars, which have been ongoing since 2020 and continue to go forward in 2022 as well. Next slide. Aim of INTC. We are here to get enterprise involved in standards activities. We need to first tell them that this impacts them, that this is not just for the internet access that we do it from our mobile phones and browsers. This is going to impact them within their organization as they are running their own internal services, which is maybe not even exposed outside the world, outside. And now, of course, things moving to cloud, this has a huge impact on them. IoT, all that things bring in a big impact to the enterprises. So convincing them that this is an important issue, you need to get involved, get your feedback, and bridge that gap between the enterprises and the IETF. Next slide. So one of the key work that we did since 2021 was the IPv6 webinar series. You saw the list when Nalini was mentioning. This is a collaboration between IIESoc and INTC, and we did this with the generous grant from APNIC and ICEF Asia. So this is a very important series. All of the material is available. We will continue to publish more advanced IPv6 topics, but before we take on that, it's important that you guys who are interested in this world go through this webinar series. Feel free to reach out to us for further discussions and questions, as Nalini was mentioning. Next slide. I will quickly cover two more events that we do, which is RFCs We Love. This is again a very informal meetups, just so that people get used to IETF environment and talking about IETF standards. We used to do face-to-face earlier, but since in the pandemic world, we have all moved it online. There are a lot of interesting topics that keeps happening: data center, IoT, network slicing, latest work that has happened at IETF, all that stuff. So look at the link here, and we will of course share the slides with you later. So all these links would be available to you to browse later on. Next slide. And this is my last slide, and then we can move on to the key of the presentation today. Connections is our flagship annual event that IIESoc has been doing. Last one was again because of the pandemic was online, and it was in collaboration with INTC and IIESoc. Before that, we have been doing physical events in Bangalore and in Kolkata, usually just before the Asian IETF meeting, so that we could invite people who are coming to IETF anyway to this part of the world to stop by in India, meet the community, talk about what is happening in IETF. We also introduced them to the work that is happening in India, what's happening at startups, what are the issues which are very, very relevant to Indian internet ecosystem, and how we can bridge that gap. So with that, we have been doing this event, which has been very successful. Again, all material is completely open. So if you want to get an introduction to IETF culture, what are the key topics that are being talked in IETF, this would be a good entry point with an Indian context set in that you could browse. And with that, I now pass on to the key speaker today, which is Mohit.
Thanks, Nalini, and thanks, Dhruv, for setting up this stage, and thanks, Dhruv, for giving an intro to the organizations. So I hope I'm audible and I can continue.
Yes, Mohit.
Yes.
Yeah, thank you. Right. So thank you very much to Mohan sir and the entire team for giving me and our team, Nalini and Dhruv, an opportunity to present about this work. So I'm going to talk about the IPv6 deployment experience that I had at NITK, and let me just add that this is a work in progress, but I'll also discuss where we are currently as I go into the details. So led by Nalini and Dhruv as the main members along with me who are helping us in migrating NITK, we have a big team. We have Mike, who is also board member of INTC. We have Priyanka from TCS Research, Praneeth, who is the secretary of IIESoc, and 3 members from my own university, PG Mohan, Ramesh Kini, and Sham Kamath. So thanks to all of them for working with me. And this has been about an year or more now that we have been working on this particular thing. So like Nalini already mentioned, it takes quite a bit of an effort to actually get into the migration and then try to complete it safely. For those who do not know, where am I talking from? I'm talking from on the west coast of India, southern west coast, basically near to the Arabian Sea. I'm in a district called Mangalore in Karnataka, and the town is called Surathkal, and institution is National Institute of Technology, Karnataka at Surathkal. Going forward, first I'll just like to talk about, because the talk has been arranged in that way, the need for migrating to IPv6 and what are the challenges in migrating to IPv6, and then finally talking about the process. So let me get started from the motivation perspective, mainly from university sides, because as Nalini and Dhruv already have mentioned earlier that IPv6 deployments have been picking up, and Nalini already mentioned that it's mainly cellular networks and ISPs that are migrating. I'll talk about what was our motivation as an academia, as a university. Why did we want to migrate to IPv6? And this is not something that's, of course, we started working with INTC and IIESoc since last year, but this was under our to-do list from approximately about 2018. So in 2018, when we were trying to manage our campus network, we saw that the number of devices that were coming to the network was increasing rapidly. And every student had 2 to 3 devices, and we have a campus where we have about more than 7,000 students. You can imagine the rise that was happening in the number of devices. So another point is that in an academic environment, we realized that there are different varieties of user requirements. Basic internet services are needed by everyone, but several times you need to provide them highly customized features for academic research and development. So for example, we used to get calls from our colleagues, and they used to say, I need a static IP. I need to communicate publicly directly. I don't need network address translator in between. So I don't need a private IP. Give me a public IP. And if, we ask why, and then they would explain the reasons, and then we had to provide. So there are different categories of requirements that we were observing coming from faculty members, researchers, students. Fast forward 2020, last year, all of us went into lockdown mode. Everybody had to use internet for fulfilling the basic, needs of education. So we had to adopt new teaching learning methodologies, and everything became remote. Theory sessions were remote for sure, but even the laboratories became remote triggered. So we have laboratories at NITK, mechanical laboratories, where you can actually understand the frequency of oscillation of a pendulum by using an Android app or a web application. So you go to rtlabs.nitk.ac.in later sometime, and then maybe you can try to access these labs which are actually deployed at NITK, but you can trigger them using a web application. There are cameras fit in so that you can actually see the physical movements of these things in NITK lab. So everything started moving online, and this was very, very time sensitive traffic, very much time critical traffic. Online exams is something that, again, challenged the kind of network that we had. For example, at our institution, we deployed Moodle instances. We had Moodle from many years, but when students started submitting assignments, we know how the pattern is. They submit it at the end, at the last minute. And there are large PDFs that are scanned through their phones, and camera resolutions are very high. So the size of the PDF and the size of the image that they upload is very high. All those things, when they started uploading, our servers and our network started putting, restrictions, and then we got a lot of challenges that we had to cover. So we understood that we need more throughput and we need scalability now, because number of students will increase in future and number of devices will also increase in future. So what can we do to simplify the network architecture? One thing that came obvious to our mind is, can we get rid of network address translator? Because it adds a lot of latency and also hinders a scalability up to a certain extent. So we started thinking, like NAT, are there any other potential performance bottlenecks that we can start thinking? And that's where we said, okay, this is the right time that we should think about migrating to IPv6. Many of our colleagues also suggested that since our network is not able to scale and we are not able to procure more servers because of the lockdown situation, no equipments are being shipped from any part of the world to any other part, why don't we go to cloud? And then we also, when we started looking into it, we found out, yes, we can move to cloud, but looking at the way the trend is, it is inevitable that in future cloud providers will not charge for IPv4. They will charge for IPv4 addresses going forward. So we said, okay, that is a good idea that we move to IPv6. migrating to cloud or not migrating to cloud is a separate decision, but I think IPv6 is a great move that we should make. We also see, as already Mohan sir mentioned during the introduction, that there's a lot of interest in R&D in the field of IoT and machine-to-machine communication, and this is all being driven by the fundamental technology IPv6. So that was about the motivation. Now, what is the significance of being IPv6 ready? What do we as university, believe will help us in being IPv6 ready? So when I was studying about this thing for my university and trying to also encourage our administration and our colleagues, I found out that, sometimes these kind of decisions that you make, for example, the decision that you make to migrate to IPv6 can really impact your R&D budget of that particular university. I have an example. This example is from National Science Foundation. That's a main funding agency for research and development in US. They had a program a few years ago, which is called Campus Cyber Infrastructure Innovation and Engineering Program. And one of the requirements that was mentioned in the application of National Science Foundation is that if you are applying for funding under this program, you need to discuss what is the status of IPv6 deployment in your university or in your enterprise, wherever you are applying from. So you can imagine that the funding agencies have started asking for the questions in their forms, such as, are you IPv6 ready? Or are you thinking to migrate to IPv6? And, like Nalini already mentioned, there have been a lot of discussions in the US government, Indian government, and many other countries. There are joint efforts being made by these governments to kind of promote IPv6. Mohan sir already mentioned that, in India recently, the deadline has been provided June 2022 for major ISPs and all, people to move to IPv6 at the earliest. So apart from, just getting ready for applying to fundings and all, we also gain a competitive edge. We can also start working with international universities and enterprises who have been also thinking about migrating to IPv6 and have been facing challenges. As I go forward to the next slide, you will know we did face a lot of challenges, but I'll talk about that because there's a dedicated slide to talk about what challenges we faced. And we have now a ranking framework in India since last 5 to 6 years. We know NIRF matters a lot, and sooner or later, the funding that will be provided to the universities in India will depend on what is the NIRF. That universities who are within top 10 or top 50 or top 100 NIRF rankings are only eligible to participate. So we get a lot of opportunities by migrating to IPv6. It's not just moving to IPv6. It brings a lot of advantages, and of course, on the way you will face challenges as well. So what was the first thing that we found challenge when we actually mentally prepared? Let us think about migrating to IPv6. How do we start? The biggest question is, how do I migrate my enterprise or my university to IPv6? We need to have practical knowledge about IPv6 and its deployment. We should know which migration strategy should be used. Do you want to go for dual stack, or you want to go for tunneling, or you want to go for translation? And we know that IPv6 adoption, as already the charts were shown by Nalini, you saw that India is leading. So mobile networks have definitely adopted IPv6 and it's doing great. But there's lack of publicly available information if an university wants to migrate to IPv6. I did not find any document being prepared or any blog or any article or any such thing where we can identify what steps a university should take to migrate to IPv6 and what are the challenges that can be anticipated and what are the ways we can fix those challenges and go ahead and resolve those challenges and move forward. I did find, by the way, when I was doing all this search, that few universities planned for IPv6 migration in India. There were documents about their proposals, but there are no further updates whether they actually moved, and if they did, what were the challenges that were faced. So this is where we sensed an opportunity that, yes, we know that the road ahead is going to be difficult. These are the discussions from last year around October timeframe. And then we said, okay, the road is going to be very challenging, but we do see a lot of benefit also coming forward. I had started interacting with Dhruv and Nalini in about May 2020. This is because INTC started very nice set of IPv6 webinars last May from 2020. And we were able to listen to long-time IETF contributors like Fred, Baker, and other people. So I registered for those webinars and I started listening to those webinars because we had decided that we are going to migrate to IPv6. And Suddenly, in the month of October, I saw an email from Dhruv, and this was not at all anticipated or not at all thought about, that IIESoc has received a grant from ICF Asia under APNIC Foundation in the year 2020. And he said, anybody who is interested in IPv6 migration, please fill up this Google form. It was never a second thought. In a single second, I filled up that form and I said, NITK Surathkal wants to migrate to IPv6. And we submitted an expression of interest immediately. We got absolutely fantastic support from IIESoc and INTC because we filled up that form. We understood what they are planning to do ahead, and then we attended all the webinars that Nalini pointed out in one of the slides earlier, and the link was also provided. We were participating very actively in all those webinars since February 2021. And good thing was we registered with IIESoc in October. So I started having discussions with Nalini and Dhruv on weekly basis. And by the time we reached to the webinar stage, they had given me a very good head start. So webinars definitely added a lot more on top of it, but we got a head start with their support. So we started attending these webinars from February that were conducted by, and we also informed our staff members, our Central Computing Center staff members, to attend these webinars because ultimately they would have to handle IPv6 going forward. One interesting thing that I would like to tell everybody here, we did mention this session was supported with a hands-on session later on. So Nalini, Mike, Dhruv, and myself, so basically we saw there was a theory session delivered, and then next week we had a hands-on session on the same theory topic. This concept, which was introduced by IIESoc and INTC, was absolutely fantastic because you listen to what actually the technology is all about, and then you go and try doing things by yourself. So then we started heading forward and said, okay, we are now getting hands-on experience on IPv6. But first thing, we as government organizations, we take services of BSNL. So BSNL is our ISP. So we confirmed whether BSNL itself supports IPv6, because if I migrate to IPv6, if I decide my university should migrate to IPv6, it's important that my ISP supports IPv6. So we confirmed, and they said, yes, they support IPv6. I'll talk in more detail about the bullet that says IPv6 address leasing option. I have a dedicated slide for that. But to cover it up in brief, there are two options. We can ISP like BSNL or any other ISP in India who support IPv6 to provide us the IPv6 addresses for our university, or we can directly lease the addresses from National Internet Exchange of India, or in abbreviation we call it as NITC. Later on, Nalini and the team suggested me that I should set up a small testbed of live computers inside my campus network so that we get acquainted with the functionality of IPv6. And I should say that it was one of the most important steps, because this small testbed that we set up allowed us to play more freely and get acquainted with the entire functionality of IPv6 before we started deploying IPv6 on the production network. Then we also prepared an inventory of how many network equipments we have in our campus, what are the applications we run. For example, the MIS that stores the student information. We have web application, website. We have so many other applications, databases and all running. So we took a stock of what are the different applications running, what are the different platforms. Are we using .NET? Are we using MATLAB? Are we using any specific software? What are the ways they are deployed? How are the licenses managed? We also looked at how we are managing stuff like our network equipment. So we typically use our open network management software, OpenNMS. So where is that deployed? How does it work? And what are other monitoring tools that are being used at NITK? So we had to prepare this inventory thoroughly and also see whether we have any older network equipments that probably do not have IPv6 support. But that was not the case in our situation. We found that all of them had support for IPv6. We just had to probably turn the IPv6 feature on. Let me talk about experiences with IPv6 migration. So as I told in one of my slides earlier, which migration strategy should be used? Because you see, my first challenge was tackled because we were getting direct support from INTC and IIESoc. So lack of practical knowledge, that gap was filled by these two organizations and their webinars and the hands-on session. Then which migration strategy should be used? So then again, I went back, spoke to Nalini and team, and they said, yeah, dual looks to be the most simple because it has very less complexity in deployment. So what does dual stack do? You have IPv4 as well as IPv6 supported. And if IPv6 doesn't work for some reason, you fall back to IPv4. So that we decided that at NITK, we would rather go with dual stack right now. Then we started experimenting on the production network, on the actual campus network. We started converting 1 virtual LAN to support IPv6 one at a time. And why we did this, let me also tell you one important thing before you try any such thing. Our students were not in campus due to COVID-19. So there were very few users in the campus LAN, and hence it was not at all very risky for us to do this kind of an experiment. But if you are trying to do this experiment, and if your students are in campus, we have to be very careful at what time of the year or what time of the month we try to perform these experiments, and try to avoid any such experiments, particularly when there are examinations or any such thing. One of my most favorite thing that I liked in the entire process of migrating was how to configure DHCP-v6 server in our university so that automatically IPv6 addresses can be provided to the interfaces on the hosts. So why this was the most interesting experience is because I got a lot of hands-on things done. My university told me to explore this along with one of my other colleagues, PG Mohan. So we both initially started using stateless auto configuration, that is called Slack. But eventually we moved then to stateful DHCP and then installed a Kia server. There is also a hands-on session that I delivered. So Nalini gave a DHCP v6 theory, and I followed it up with a DHCP v6 lab, which is also available in the webinar series link that Nalini and Dhruv provided earlier. So this way, I was pretty happy that we were actually getting support from INTC and IIESoc. But in the process, I myself from NITK was able to contribute back something to INTC and IIESoc by delivering at least one hands-on session where I explained how we can set up a stateless auto configuration server, or you can configure a stateful DHCP v6 server in your own organization. And that was a very, very fun experience. And I would say definitely people should try doing these kind of things. Then further, we also from NITK participated in one more hands-on session where I explained how we can enable IPv6 support in virtualized private cloud of AWS. Nalini just mentioned a few minutes ago that AWS has support for IPv6. So there is a separate demo that we provided, and we showed how you can enable IPv6 in the VPC of AWS and its subnets within it. Another thing that we experience is that when you complete all these experiments, then comes the main decision. Okay, we are now ready to go ahead and ask for address block either from your ISP, or you can ask it from NITC. But the question is, how many addresses do you need? How many IPv6 addresses should you lease? And that particular whole thing is called address planning. So you should have your entire network topology in your mind, sit with a paper and start planning. We call that as address planning, and it might take several iterations. And one of the most important thing in the entire IPv6 migration process is how well do you do this address planning? And it has to be done very carefully. Let me take a simple example of how our address plan was shaping up, and it's still under progress. So what we thought is that NITK Surathkal has one campus right now. It's called the Surathkal campus. But 2019, there was already a proposal, and many people know about it, that there is a NITK Suratkal's another campus coming up in Bangalore, which is called the Extension campus. Due to COVID, the whole process has been delayed, but there will be soon a Bangalore campus. So we know that our university has multiple sites, and there are many such universities in India who have multiple sites. Okay, so you need to first ask yourself a question: is this a standalone campus? Are there other sites of this particular university? Or in future, is the institution planning to grow? So we already saw that our institution was planning to go to Bangalore. So I have added, you can see, one Surathkal campus, one Bangalore campus. Then if something goes wrong in the Surathkal campus, we should have a disaster recovery for Surathkal campus. So if anything goes wrong, we should be able to get our data back from the disaster recovery site. So we thought there will be one site dedicatedly needed for disaster recovery for Surathkal campus, one disaster recovery site for Bangalore campus. And if we migrate to cloud tomorrow, we start using a lot of resources in the cloud, probably we might not be looking forward down the line to pay for IPv4 addresses. So why not have IPv6 address of your own and use those addresses? That's a very interesting feature that I myself found out when I was doing the AWS demo for the IPv6 webinars for INTC and IESoc, that AWS allows you to use your own IPv6 address block in their cloud. So we thought, why not explore. Maybe other cloud also provide these kind of things. And in future, down the line, when NITK migrates to any of the cloud services, we can probably use our own IPv6 over there. So we thought, let us have 4 bits in our address plan that are just representing sites. So we said, okay, what are the other things that we need? Okay, we thought we have several different sections and divisions in our university. For example, there is a dedicated building for academic section. There are so many different academic blocks. Each department has a separate academic building. There is a common administration building. We have central computer sections. We have research divisions. We have residential areas, which includes hostels, which includes guest houses, which includes faculty quarters. We also have separate buildings and places for sports and recreation activities. So we thought, okay, we can cover all of this for the next 8 bits. So you can see 4 bits to represent sites, 8 bits to basically represent which section the data packet has to be forwarded to. The next 8 bits might be required for buildings within the section. So for example, as I said, academic, for example, we have about 14, 15 departments. So each department has its unique building, and we might need some bits to represent those buildings. I'm going in a very quick manner here due to the shortage of timing, but I'm just giving you a quick idea of how an address plan looks like and how it can be structured. And then finally, you reach inside a building, there might be several virtual LANs inside that building. So for example, if you come to our building, we have 7 to 8 floors. We can have VLANs, multiple VLANs in each floor, or even each floor can be a VLAN in itself. So we reserved next 8 bits for that particular purpose. So, and the last 64 bits can be used for the host interfaces. So you see now, last 64 bits for the host, then the 8 bits for representing the virtual LANs, 8 bits for representing the buildings, 8 bits for representing the sections or divisions, and 4 bits to represent the sites. So totally 92 bits will be used. We know that IPv6 is 128. So now you subtract 128, you subtract 92 from 128 and you get 36 bits. So basically that means you have to request for a /36 address block from NITK, or you can request for this kind of a block from your ISP. So this is a very quick look of how address planning looks like. So first 36 bits of IPv6 address will remain fixed and will be reserved for your university network. But the next bits are under your control of how you use those bits. So I explained, we will use, after this first 36 bits, we will use the next 4 bits for highlighting which site we are sending the packet to, next 8 bits to highlight which department we are sending, which section or division we are sending the packet to, then which building, and inside that building, which VLAN. So you can see how the hierarchical structure looks like and how the packet is routed. And there are very interesting discussions. There are dedicated webinars that Nalini and Mike took, and they gave very beautiful examples of how address planning should be done, keeping route aggregation in mind. And also they showed, hands-on sessions of how all of these things work. Now, let me talk about leasing IPv6 addresses. I told you I will talk about it in detail. So this is a slide. Option number 1, you can check with your ISP whether they provide IPv6 addresses and can they support your network or not. But one thing that you should be careful while doing this is that if you change the ISP in future, the IPv6 address block will also change because a new ISP will come, and now the address block that you get from the new ISP could be different from what you had from the previous ISP. Otherwise, you can go for solutions such as multi-homing, where you have multiple ISPs in your network and you can just use the services of both these ISPs. So even if one of them leaves, you still have the another one to operate with. Second option is you can directly lease the IPv6 address block from National Internet Exchange of India. But even before you do that and talk to the NITK, first of all, you should talk to ISP, because after all, the routing support has to be provided by your ISP. So you should ask them what is the readiness of IPv6 from their side. So we did that with our case. Our case was BSNL. So before we go and lease out IPv6 addresses, we asked BSNL whether they support IPv6, and they said yes. Then the second question we asked is, if we get the IPv6 addresses from NITK, will you be able to provide us the routing support? They said yes. So these confirmations are important before you approach NITK and tell them, okay, we need an IPv6 address block. Now, suppose you are clear and your ISP says everything is good to go, then you have to submit an application to IRIN. It's called IRINN, Indian Registry for Internet Names and Numbers. The website is irin.in. It's a division of NITK which handles INTC's registry of names and numbers to actually lease your address block. But when you submit, so there's an online application that you have to submit. Besides that online application, you have to sign an agreement with IRIN. You have to submit the KYC document. So you have to tell whether you are a university, or are you a school, or are you a private limited company, or you are any other kind of a firm. So all those KYC documents have to be filled up. You don't need more time, maybe just 2 to 3 documents, and within half an hour, 1 hour, you can fill it up if you have all the information in with you properly. And then you also need to submit a justification document in which you have to include the campus network topology and why are you asking for this one. So for instance, if I finalize this address plan, which I discussed on slide 31, and say that I need a /36 address block, I need to justify why am I requesting for a /36 address block. And let me tell you that NITC might come back to you and say, we don't think probably you might need /36, you might need something else. You have to justify, you have to have discussions with NITC. It's not you request for /36 and it's granted. It's not, it doesn't work that way. So we have to do to and fro discussions with NITC. They will also provide support in terms of understanding why do they think that kind of address block might be sufficient. And finally, you also need to pay the fees directly to NITC for leasing the IPv6 addresses. So let me spend one slide on what is the cost of leasing IPv6 addresses. If you go with option number 1, that means if you are directly taking IPv6 addresses for your network from your ISP, then it totally depends on ISP. Whether they charge extra or whether they don't, it depends from one ISP to another. So I don't have much experience on that. But if you go to option number 2, that means if you want to directly lease the IPv6 address block from NITC, then you might want to check this link, which I have put up there. I'll share the slides with Mohan sir, so that this can be forwarded to all of you. Otherwise, you can just go to irin.in and you will find this link also there. So if you are a new affiliate, in which case, suppose if NITK goes to NITC, we are a new affiliate. We haven't signed any agreement with IRIN before. So this will be your first time agreement signing with IRIN. So a one-time sign-up fee of 25,000 Indian rupees will apply. And in addition, so this is a one-time sign-up fee. You don't have to pay this every year. But in addition to this 25,000 for the very first year, you have to pay the fees according to the address block that you request. So suppose, for example, I have taken in this presentation /36. So for /36, you will have to pay 21,999. So you can take it as 22,000. So 22,000 plus the applicable taxes. And taxes will vary depending on what kind of organization you are. Are you a government organization? Are you a private organization? And depending on that, the taxes might vary. We don't know. But if you quickly want to check how much will be the fees and you need help in terms of fee calculator, there is a link at the bottom of the slide. You can go there and you can see if you go for /36, how much you will have to pay. If you go for /48, how much you might have to pay. And please keep it in mind that this is a annually recurring fee. So you have to pay this fee every year for keeping those IPv6 address blocks with you. So this is about the cost of IPv6 addresses. What are our next steps and where do we expect the community support? Like Nalini already said, we also might have soon some collaborations with IEEE. I am myself right now very actively engaged with IEEE Mangalore subsection. So next steps for us, first of all, at NITK level is to think about IPv6 application conversion. So we have to now see that what are applications at NITK, what are deployed in the network, and how do we convert them to support IPv6 and work on top of IPv6. We also intend to prepare a template for IPv6 deployment that can be used by other universities. So we can put all of this into a nice little framework and then pass it on to other universities so that they can use this framework and start their journey of migrating to IPv6. Also prepare some kind of frequently asked questions to help others interested. For example, many people ask the question, how much will it cost? Or how do I start? Or whom do I approach if I want an IPv6 address? So that's something that we are looking forward to. At NITK, we are also planning to set up an IPv6 lab so that people who are interested to migrate to IPv6 can use this lab. We plan to also make it remotely accessible if possible so that they can be at their own locations but still use this lab. This is about the lab which I said Nalini and team requested me to set up at my university so that we can play around with this lab. So such kind of things we are also planning here. And at the same time, I take this opportunity because there are many participants here who are from different universities and enterprises. So we look forward to know from you if you have already an experience for migrating to IPv6, and if there is any input that you would like to give. So any kind of suggestion from the community would be highly appreciated, and do let us know what did we not cover in this presentation, or not just the presentation, but in the process that I was describing, is there something that I missed out? So I would like to just end my presentation by giving a word of thanks, very high regards and gratitude for all the support that NITK has got from IIESoc and INTC, and thanks to ISIF Asia in Epinic Foundation for funding the IIESoc team for conducting these webinars, without which I don't think we would have gotten our very first step to migrate to IPv6. So thank you, everyone. And if you have any questions, these are the email addresses to whom you can reach out, and we'll be more than happy to know from you how we can help. So that's it from my side. We are ready to take some questions, and back to Mr. Mohan. Thank you, sir. I hope I was audible. I hope I was audible.
Yeah. Thank you, Dr. Mohit. Thanks, Ms. Nalini, Dr. Mohit, and Mr. Dhruv for presenting a very useful and interesting webinar on IPv6 migration, need, issues, and process. I think we have explained almost everything that's possible within the time available. Still, there are a few questions actually, so we will start with the first question. The development of IP-enabled devices and the advent of IPv6 lead to the explosion of new connections joining the Internet of Everything. What are your thoughts on this?
Can you repeat this question?
There are a lot of development of IP-enabled devices, right? Mm-hmm. And also the advent of IPv6, which we were discussing. Mm-hmm. So these things lead to the explosion of new connections, right? So it is all joining the Internet of Everything, right? From Internet of Things to Internet of Everything. What are your thoughts? How it will go along?
Do you want to take this, Nalini or Dhruv?
Yeah. Let me try, and then and see if I'm understanding what the question, and then you guys speak too. What I think you're saying is, because we will have so many more things, maybe bandwidth requirements will also increase. Is bandwidth requirements also? It's not just bandwidth requirements, because if you have routers, servers, load balancers, everything along the way, which will need something. I think Mohit's doctoral thesis was on a congestion algorithm. And so is that, let me, Mohan, sir, is that the question? Is how this will impact everything?
Yes, partly yes, you're right. So the bandwidth requirement will also be more. You're right. So
no, I don't know. I mean, there's what can I say? But yes. The other thing too, and I'll let Mohit and Dhruv get a word in edgewise. One thing we don't talk about enough is power requirements. It's like we can't have like every single bit of energy in our world spent servicing routers and servers for the internet. As I said, Dhruv, Mohit, do you guys want to comment on this area? All I can say is yes.
So yes, there is this is an interesting problem. This is a future-looking problem. There are in fact a lot more controversial topics from something which even my organization has proposed. So yes, this is a big topic. There is a idea that whether our current IP and IPv6 can handle it. It looks like it. At least the latest results from COVID, this is a small subset, but COVID just increased the the demand on the network immediately but IP was able to be elastic enough and scale. So that's our current expectation, but we don't know really about the future. Future is unknown, lot more research, and this is needed. But a lot more minds are looking at this problem that, especially with not just Internet of Things, but Internet of Everything. Look, if you look mathematically, IPv6 address space is quite big enough. So we don't really need to worry so much about the addressing part. But what about everything else? The congestion and everything. Yeah, that part and quality of service that we are expecting, security, privacy, those things are way more important in all the things being intelligent. That's much more scary, and that's where more research needs to be done. Not so much on, can everybody have enough IPv6 address for everything? So that is not a big problem. The problem is privacy and security.
Okay, thank you. And another question is how this IPv6 affects the common man, right? Because now common man is using so many modern gadgets and all, right? So because they are all tech savvy, and most of the people have started using a lot of devices with IP enabled and all that, right? So how it affects, or what is the impact on them? It is also one of the questions asked by one of the participants.
I think that's the beauty of internet architecture, that if you are end user, actually it should not matter to you. It should all be very hidden to you. That's what the beauty of network layer is. If you are working in application side, things should be hidden. But we are all tech savvy, as he says. So go use your mobile phone. First thing that we should do is go and find out what IPv6 address your mobile operator is offering you right now. And there are apps for this. Net Analyzer is there for both Android and iOS. This was, in fact, the first thing that we did in our IPv6 webinar. That go and find out, what is happening on your own devices. And on your mobile phone, you will be surprised that most of the Indian mobile operators are already providing everything on IPv6. Go and find the DNS addresses for your favorite website. Things already are quite a bit on IPv6. Now, what happens is, this is the infrastructure. When you are thinking of common man, we think of what's happening at the application layer. We are thinking of security, privacy. This is all network and infrastructure layer. When it works, nobody thinks about it. When it breaks everything.
Yeah,
I would like maybe Mohit or Nalini to add a few words. Otherwise, I think spoken enough on.
Mohit, do you want to go ahead and chime in, and then otherwise I'll end up something. Yeah.
You can go first. No problem.
So one thing that's kind of interesting, this is a problem we've seen with some of the ISPs as far as affecting common man, is some of the very old devices. If you're holding on to some very old end user devices, they may not have IPv6 capacity. And so I know that some of the ISPs who have IPv6 only backbone, they are having to do support for these keep IPv4 support only for these very old devices. And so it doesn't really impact common man as such. It's just that through time, maybe people should think to upgrade their devices. I know this can be difficult.
Yeah, no, I think, so I agree with Dhruv and Nalini. So see, it shouldn't actually matter a lot to the end user. So for instance, when the students are in the campus, I'll always connect everything to my university network and talk about it. So if I see students coming to the campus, they should not be affected whether we have IPv4 or IPv6. What matters to them at the end of the day, or in Internet of Everything, what is the most important thing is the quality of experience. So what matters in IOE is QoE. That's what I would say. So the quality of experience that you deliver to the user is of prime importance, and not exactly, whether it's IPv4 or IPv6. Yeah.
Okay. One question is the implementation, whether it is IPv6 protocol, whether it is at the expected rate, or is there any, has it reached a stagnated point or stagnation or something like that? or it is not advancing more than 34% worldwide. That's what somebody has asked actually. So why can't it go further? Why, what are the reasons? Why it is not going as fast as we expect?
Mohit, go ahead. Yeah.
No, I was saying you are the best person to answer this question. You have been knowing about this whole thing since the beginning.
Yeah, well, this is actually why we have started this project, because the bulk of the people who have not gone are the very large private managed networks. Many of the people in home, and we knew all along that this would happen. We knew all along that home networks and home users would be first to go. And in fact, this is why we started this project. This is why Aaron and AP Nick are supporting, because the problem is, one time I was on this maybe 10 years ago. I was on a design team to develop the IPv6 migration plan for a very large consortium in the United States. In fact, that consortium alone is responsible for 4 or 5% U.S. economy. And I made the plan. I presented. I said, okay, this is 5-year plan. And one of the managers looked at me and he goes, "This is 10-year plan." And so this is the problem. Is these networks are enormously complex. For example, when you go to your bank, you don't expect to have fraud. You expect to have complete security. It's not like doing some kind of query to a search engine. You can submit twice. It doesn't matter. But you don't want mortgage payments taken out twice. You don't want somebody else taking money out of your account. This is a very difficult job. And also too, like, everything has to be available all the time. They are very, very careful. And so that's why this is a long-term job. But many people are working together and helping. And again, as Mohit and Dhruv pointed out, we will expect to think more collaboration in this area with IEEE. And I think things such as what Mohit has done is this template of how to do universities. I think universities must be the leading edge of this, because not only they will have, the students will then learn, students will go to industry. You need to have this base of people who knows IPv6.
Just to add to what Nalini was saying, another interesting thing is, especially we working on the technology side, and I have had this discussion even during connections when we asked, folks who were involved from the start of IPv6 development, and you ask them, and they would be surprised. They thought that, at that time, the need for IPv6 was really strong. The addresses were just going to get exhaust. People were worried that what we are going to do, and that's where, in that environment, the IPv6 standards and implementation started. But the actual deployment has lagged, because market doesn't work on those principles. Market has a different set of principles. And in fact, even something in IETF, what we did is we came up with too many transition mechanisms, and those seems to be working. So when things are working, people don't want to change that. And there is the money and the effort involved in moving to IPv6. Then there is NAT and transition, which seems to be temporary solutions when IETF was developing, but that's what you don't have a control over. Once the technology is out there and it is working, it's continued to be deployed, and it will be there for a little longer. So now what has happened is, of course, the governments are looking at it, and everybody thinking IPv6 is future. And if we are considering our country to be leading in this, then it needs to be mandated. So it's no longer can be a business interest, it needs to be a national interest. It should be user interest. And that's where we think that both US and India are thinking in the same thing, that we need to be future looking, and we need to make our infrastructure future proof, and not wait for just the business factors to take it. And we hope that's the direction we go in. Thank you.
Thanks,
Is it the dual stack implementation was detrimental for IPv migration?
Dual stack, IPv6 only, even in, we think of, like as Nalini was saying, that IPv6 only geo was planned but couldn't, because the enterprises, or there were equipments that needed very small scale. There are still 97% IPv6, but you still had to do something to make sure that the legacy things can still continue to work. And not everybody can do what happens with that operator, because they were greenfield. They had the luxury of buying new and building something from ground up. But when you have already a huge investment and things working, that's a different ball game. And that's why you are seeing a little bit more lethargy in other much older ISPs, and in fact enterprises. Enterprises, in fact, are much more older than all these ISPs. They have their internal mainframes and systems and all that stuff. Moving them to IPv6 is a total different thing. And in fact, we did one webinar recently which was only targeted towards IPv6 at mainframe, which is something that we don't even think about, but that's a huge issue that enterprises have to worry about, which is kind of hidden to the outside world.
What type of DNS server resolution, when you have dual stack? See, are there any problems, because when people work on IPv4 and IPv6, the DNS resolution of website addresses, will there be any problems, or how it is handled?
In fact, there is this happy eyeball system where you first try on IPv6 works, you immediately use it. Only if IPv6 fails, then you move to IPv4. So those things have been working for a long time. In fact, Google and most of our Netflix, all the content providers are already on IPv6. You will be surprised how much things are already on IPv6. And if you have an IPv6 only, at least on your mobile phone, when you are on a mobile connection, things would already be on native IPv6. It's like inside our enterprises and in our educational, where we are in IPv4, we are not seeing enough, but all of this has been working for a very, very long time.
Okay, my last question is, we know it's a process, because migration from IPv4 to IPv6. One participant has asked, what are the top commercial tools available for migration from IPv4 to IPv6?
I'll let Nalini answer that. She's in this.
I'm laughing because I'll say basically none. I tell you something. I do commercial software for a living, and if I can do a product which can do this, I will have done it. It slides right off your tongue, as I say. Oh, we need some commercial product to do it. Yeah, okay, you write it. There are a lot of challenges I will take on. This is one area which parts of it, I've been thinking there's some parts which is potentially possible, and it has to do with one maybe area in application socket conversion. Even that is very difficult. I think unfortunately, because what is the problem? Every network is different. Every network has been built differently. Every industry has its own application. Each application is maybe homegrown and written. There are some commonalities. And as we go forth, then we may find a few little places, where it's possible. And I tell you something, if you're an independent software developer, this is a great, join our team and join and see if you can find some area which you can automate. My plate is full right now with cryptography. So yes, guys, anything else you have to say?
So the only thing that comes to my mind is I remember when we were writing software within our company, we used to have these automated tools which used to make sure that we are not assuming IPv4. only things, and those things can definitely be automated, that your code is not like, hard coding things or not assuming that everything is IPv4 only, but those are like, very simple code analysis, but not something that will help you in the deployment side. That will only take care in your application development side going forward, that too, not something that you can do retroactive.
Is there anyone offering migration as a service? Is it, I mean, why not IESoc can start something like that?
Yeah, we are a non-profit, so we are working within that this thing. But if this is an idea, if somebody wants to take forward and make it for profit, we will definitely help whatever we can from the non-profit side.
So, Mohan sir, just to answer the question, so the form that was circulated by Dhruv, many companies, I think Dhruv will be able to answer that. Many companies registered for it, even many academic universities have registered for it. So, IIESoc is already doing best to provide service in collaboration with INTC, and that is probably the reason that at NITK, since last 1 year, our spirits are still high that we will complete the migration. So, so it's being provided as a service, and I'm so glad to tell you the kind of the technical inputs. Let me take liberty to add this point. At one point, Nalini had to, so in the small testbed that we had made, it was a controlled testbed and it did not have any original network data over there. It was just a small testbed only for IPv6 experiment. I sent around 25 or 26 packet capture files to Nalini, and she parsed each packet capture file one after the other, prepared a slide deck highlighting what's going wrong, and then she discussed it with me. And this is amazing support that IIESoc and INTC is providing. So I would just suggest more and more universities to join. Maybe Nalini wants to talk about the consortium that is also being planned to enable more support to be provided for people.
No, is there any way that we can collaborate and start such a initiative in India?
Definitely, why not?
Like bringing the people, basically this consuming a lot of efforts. First of all, everyone has to understand their own network and take stock of situation. So which is not normally happening. Many places the manpower is not static. There is dynamic. So a person who makes a study, maybe after 3 months, he may not be there. Documentation is very poor level. So
Yes.
which means that a lot of process elements have to be put in place, and some sort of a help center or maybe a group which can provide continuing support will be a long-lasting solution. Is there any possibility that we can all work together in this area?
Wonderful idea. Let's plan this. I think this is tremendous, because also too, then, as with your help, with IEEE help, we can scale the effort too. Each one teach one. We all teach each other, and everything grows. So then, because we are only a small team, but if others also are there, then we can scale. I think let's definitely take this forward.
Yeah, Dr. Mohit, can you just approximately indicate how much of man days have been spent in the project?
So it's hard to translate it that way, but let me tell you that we did not work on a full-time basis only for the IPv6 deployment. It was kind of added in our daily activities bit by bit and piece by piece, and we haven't been rushing towards IPv6 migration because we wanted to understand the process in depth. What is most important is that I will be honest, that we didn't want to hire a firm to manage IPv6 for us. We want us to manage our IPv6 ourselves. And for that, we need to spend the amount of time. You can see Nalini, Dhruv, Mike, they have spent years on IPv6. So we did not expect that migration will happen in 6 months or 5 months. So we know that it might take 1 to 2 years. So we started this effort in October, and we have been working on it. In between, during the lockdown time, we stopped everything because we could not perform any experiments on the infrastructure because if our infrastructure goes down, students' studies will be affected. So we didn't do anything in the 3 months from April, May, June, July, I can say. But we started working from October last year, and right now we have kind of completed address planning, and we are trying to go to the next step of thinking about where to get IPv6 addresses now. Should we get it from ISP or should we get it from NITC? And once that is done, we will be starting to once we have our own address block, we will start migrating to it. So I would say anybody willing to do same kind of an effort that we have done, please keep it in mind. 1+ year, 1 to 1.5 years of time without any pressure on everyday job. It's like you keep working little bit on weekends, and most important is the team formation. So if you form the team correctly and everyone does their due part, you will see good amount of progress in the first 2 to 3 months itself. But then go slow, go steady, do it correctly. That's the point.
Yeah, particularly, one of the participants has asked, the support from top management is lacking, and then, it is a major bottleneck for this type of initiatives. And see, these top management definitely, they would like to have some sort of, the duration of the project and what is the cost. And these are all upfront, they may be requiring. So that's the reason I was asking, what is the effort involved from the enterprise IT team, if they are embarking this type of project. So some amount of knowledge, maybe, definitely. So we can possibly, the health center, what we are planning, should be able to translate certain activities into time and money, so that, easier for convincing the top management.
Yeah.
So
you will need to.
Of course, there's the advantages and then the pressure. See, ultimately, the government's, making it mandatory will drive the initiative. But at the same time, it will put the pressure on the in-house IT team with very little time they will be forced to do. In this process, the disaster, what they will have to face may be much more dangerous. That is what the thing.
Just to add one point that, of course, the government is putting the mandatory deadlines and people have to move forward. But one very important step, every step is important. I'm just emphasizing in the context that we are discussing that the inventory management that you do, the inventory collection that you do, that what are your devices in the network, that will help the IT team to understand how long they will need to migrate. So for example, if they have mainframes, then they need to learn how to enable IPv6 on mainframes. Like Dhruv said, there's already a webinar on that we did. Now, one important point. Once you move to IPv6, your network will no more have network address translators most of the times, right? So you can directly reach into the network. So security and the firewall configuration and the devices that you need for your firewall to run, whether you have them in place or you will have to procure. So that will decide your financial aspects, basically. So the inventory checkup that you do before you migrate to IPv6 as to what I have, what I will need, will tell you the answer, how much time and how much money will go into this migration.
I hope this information will be made available the FAQ, what IESoc is doing, right? So these are some information will be there, right?
Yes.
So let me put one more thing in. One of the biggest costs, and I know one of the biggest costs quite a few organizations have pulled back, is because they have not had the training. This has happened in the U.S. many times. And in fact, we're talking with people right now, and once they can make public, they will say publicly, there are a number of organizations that are talking to us about making our classes themselves a part of the curriculum that everybody on their tech side has to go through. And in fact, we've already put them on CDs. We had to burn them on DVD for some organizations who could not go to YouTube directly. And we will continue because, this coming year, we are bringing in the IPv6 and IoT team. We have IPv6 and 5G coming up. And so to me, I tell you, I've been through this for a number of years. And if we can take the training task off the table, so now upper management can't say, I need to spend $10,000 per person training. No, already look, see. And also to me, I think too, with our collaboration, we can say, this university has gone, this university has gone, this university has gone. So we have a track record. Say if they can do, they have taken the classes, this is their experience, you can do also. I don't know what you guys think about that.
Any idea about how many universities in US have migrated, or almost all have migrated? Is there any statistics available?
No. A number have, and I will tell you, the very first people in the U.S. to migrate were universities. They were the first. But that's a very good question. I don't think there are these statistics. We should try to get. Again, that's another project. Maybe we can take along collaboratively, and which we should, is benchmarking throughout. Is like, where did we start? We did these things. We now have 5 more. We now have 10 more, and so on. This is a very discrete project that I think we should take on. We can measure, is the mail server on IPv6? Is web server on IPv6? At least the externals we can gauge. Do they have allocation from ERN? You know what I mean? We can at least test some of these.
And just to add to Nalini's point, so Mohan sir, the article, IEEE R10 article that we wrote, in that one of the references, one paper is available which gives you an idea about how universities have migrated to IPv6. It's a 2017-18 paper, but it will actually give you a fairly good idea about it.
No, I'm only asking about the current status. No, basically the thing is there is ISOC, IIESoc, has it done any survey on this? Any survey has been conducted? Like
No, not yet.
No, not yet. Okay.
Okay.
Excellent. I think the excellent overview for people who have been having this doubt, migration, what is going to be the thing, what effort involved. It has given a overall picture so clearly, for both the INTC as well as the IIESoc. They are pitching it with support for many of the areas in IPv6 deployment, and your own case study, and where you are setting up a center. People, I hope people can come and visit the center, right? Your center.
Definitely. Sure.
Yeah.
More than happy to.
Yeah, and incidentally, what type you are mentioning about the test bed? Initially you got the test bed, and is it replicable by any institution?
Yeah, we are planning to make it replicable so that we can provide it to you and you can set it up. So that those things are also in the plan.
Yeah, that way, that most of the institutions, they can start learning by doing it. If the test bed can be replicatable, that will be the first step for them, to get into this migration process. That will be a long way. It will be helpful. So thank you, Ms. Nalini, Dhruv, and Mohit for the excellent presentation. In fact, we must thank Nalini for getting up so early on Saturday, where it is a holiday in US, and we know that. But anyway, in spite of that, now she has taken pains in getting up and then trying to exchange our views and educating us. Now I request Mr. Kamalakannan, our Vice Chairman CSI Chennai, to formally propose the vote of thanks.
Thank you, Mr. Mohan. And of course, it's been a wonderful session today. All of us, as you know, we have been talking about, thinking about IPv6. But today, I think I personally learned a lot as to what exactly IPv6 is, what are the challenges, and why we should actually make it mandatory in many enterprises. So thank you all very much. And especially I would like to thank the speaker, Ms. Nalini Elkins, who President of INTC and CEO of Inside Products Inc., who very nicely introduced the topic in the beginning, articulating tracing the history of IPv6 and presenting a brief status on the migration across the world, including India, and why it is important. So thank you very much for joining us. Again, as Mr. Mohan said, thank you for getting up so early and talking to us in spite of the long Thanksgiving traditional holiday in Western world.
You are muted.
You are unmute. KK, unmute.
Oh, sorry. I think it got unmuted by itself. And I'd like to thank Mr. Dhody, also President of IEESoc, for clearly articulating the various roles of the organization that are involved, IETF, IEESoc, and INTC, and their relentless efforts in promoting IPv6. See, these are all, I would say, thankless people who are interested in who are interested in the larger benefits for the society and who are actively promoting without waiting for any returns. So once again, Mr. Dhruv, thank you for joining us. And finally, of course, to the main speaker, Dr. Mohit Tahiliani.
Another participant has joined along with Nalini.
Oh, welcome. I think it's interesting to everybody across the species. So, and Dr. Mohit, the main speaker, assistant professor of CSC, NITK, Surathkal, thank you for joining us and narrating a brilliant case study of how they implemented that in their university, and right from what was their motivation to move on and how nicely they had planned and what are the challenges they faced and how did they overcome them, and clearly articulating the various steps in terms of how to organize a project, and also going into the details of the various possibilities or various solutions that are possible and advantages, disadvantages, and also sharing with us the templates that are already available. I think he's a treasure house of IPv6, including that lessons learned, best practices, all of that. Thank you, Dr. Mohit, for sharing with us all those details, and also sharing the links that our participants can use.
Thank you.
And to all the participants who joined us today, in spite of this being a weekend, and who joined us across the world, right? We have seen someone joining from Brazil too. Okay, so quite interesting topic. Thank you all for joining this session, and also the office bearers of 3 organizations that have jointly hosted this function today: ACM Chennai chapter, and IEEE CS Madras chapter, and Computer Society of India Chennai chapter. So thank you all for joining us today, and once again, thank you the speakers for your wonderful session. Thank you so much. And before we close, I just wanted to give a brief update on the upcoming programs for the benefit of the participants today. We have a symposium on 3rd December. It's called Research Scholars Colloquium 2021 on Intelligent and Smart Systems. This is a symposium organized in honor of Dr. F.C. Kohli, Fakirchand Kohli, who is hailed as a father of Indian IT. In fact, today, I think, today or yesterday was yesterday was his anniversary, first anniversary. Okay, so this is being organized by SSN College of Engineering in association with the organizations that I mentioned earlier. And we have another interesting webinar on 11th December on disruptive trends and future of IoT in India by Mr. Sunil David, Regional Director of IoT, India and ASEAN region from AT&T, Global Network Services India Private Limited. So please stay tuned to us on these days as well. Once again, thank you all.
And then one more on 28th, the talent acquisition.
Oh yeah, sorry, I forgot, sir. Yes, on talent acquisition, we got one more, on 20th December. Please do join us. Once again, thank you all for joining.
Thank you. Thank you, everyone.
Thank you.
Thank you. Have a great day.
Thank
and
you.
have a good
Have a
night.
great day.
Bye.
Thank you for the opportunity. Bye.
Bye.
Thank you. Thank you, Dhruv. Kiran?
Thank you, Mohan sir. Thank you.
Thank you, sir. Thank you, Bhaskar.